Good afternoon, everyone, and welcome back to the CiscoU Theater. My name is Patrick Gargano. I'm the lead content advocate with Learn with Cisco. There we go, Learn with Cisco. Thank you so much for coming to this session. I'm really excited about this one today. Thanks for those of you that brought a packed lunch. That's an excellent option. Like picnic, CiscoU Theater. Yeah, really excited about this session, not just because about the topic, but I've been talking about doing something like this with Lexie, honestly, for almost, I think it's 2 years now, and just it could never work out, And finally, she's here with Eric to talk about this, space networking. Generous, smart, funny people. I'm just here to kind of moderate. I'm going to be throwing questions at them, and I'll be keeping an eye on the WebEx space as well. So if ever there's something you'd like to ask, but you didn't get a chance during the session, that's fine. I'll forward them off to them, and they can then reply as well. Once we're done the half hour, if you do have some extra questions, we'll then just kind of leave the space so that the next session can get set up, but we'll just kind of hang out here. Lexie, Eric, go for it.
Okay. I'm Eric Peterson. I'm a tech fellow for networks and cybersecurity at Blue Origin. I've been working in aerospace for about 7 years, and I work on a wide variety of different programs.
And I'm Lexie Cooper. I'm a network integration engineer at Blue Origin. I work on the New Glenn rocket and integrate the network that Eric designed. So this is Packets in Space, networking for the final frontier. Okay. So I guess we sort of introduced ourselves already, but you want to give a little more detail, I guess? You work on a wide variety of programs, right?
Yeah, my background is not in aerospace. My background is in kind of a variety of things from cloud, data center, service provider. I've even worked on kind of old school PBX telephony and things of that nature. But now this is kind of what I work on, and one of the things that we want to talk about today is kind of the idea that you don't necessarily have to have an aerospace background to work on the things that we work on. Yeah.
Both of us came from, I think we were talking yesterday about, we came from like Cisco Networking Academy, right? That was where we got our start. So it was pretty cool. So like I said, I'm avionics integration engineer and network integration engineer. I have a background in like ISP data center networking, so pretty traditional. I got my CCNA before I started working for Blue, and I'm honestly just happy to be here. Okay. So first of all, before we get into it, some examples of questions that unfortunately we cannot answer. Please don't ask us. We don't want to get arrested, okay? So there are some things we're working under, like some restrictions like NDA, proprietary stuff, and ITAR. So unfortunately, questions like this, we can't give you details on, right? Because we'd get arrested or fired or something.
Both.
Both at the same time.
So,
right.
Unfortunately, as much as we might want to answer them for you, we can't. So this is more of like a high-level overview about how space networking works and some of the cool stuff about it. So.
All right, so this is where I step in. I get to ask this question. So what's been the hardest lesson to learn after moving from what they were doing before, right? Data center stuff, telephony stuff, going from what you guys know as traditional networking into aerospace?
Super crazy to move into it from traditional networking. I came from a NOC role, and so for me personally, the hardest, I guess the most difficult thing to start learning immediately when onboarding an aerospace company is systems engineering. I wasn't quite, we have a network is a big system, right? So all of us are kind of used to it in that way, but I went from just the network being my system to a giant rocket. And it's interesting in aerospace how, you've got your enormous, large system, the rocket, for example, and within it are a bunch of smaller systems. So the network is one of those smaller systems. And you've got requirements for that network that come from directly, they flow down from the larger vehicle, the larger system. And so understanding both how systems engineering works and how those requirements for the vehicle actually apply to the network that we're working on, that was a pretty big adjustment for me personally. How about you?
Sure. For me, I think maybe it's a non-technical item. I think it's patience. I've been working for Blue Origin for almost 7 years. I worked on the New Glenn rocket for that entire time. So, for over 15% of my life, I was working on this thing that just flew this spring. So I think for me, the patience aspect is the kind of idea that you don't get an immediate payoff, right? These things take a long time to develop. They take a long time to build. They take a long time to test. And you really have to have an intrinsic self-motivation and desire to see it through, because you're not getting feedback along the way like you do during a normal project, right? Where you might have, you might be doing some engineering for a network deployment, and you get to run it out in the lab, and you get to do a preliminary deployment, canary deployments, those sorts of things. You don't really get that feedback in aerospace. So you are just kind of sitting there the whole time saying, man, this thing's gonna,
is this gonna work?
Right, next year, the year after. I think the other thing is just how unforgiving it is. Lexie and I have a saying that it's always something. There's nothing that we've ever done that we've had a design and put it into place and it's worked the way that we planned to. There's always something that goes wrong that you expected to go right. Even as an experienced designer, things that you take for granted just don't work because of the environments or the systems they need to interact with, or those sorts of things.
Yeah.
So those would be probably the two biggest things for me.
Be as prepared as possible, and something still goes wrong.
Right, you just have to be ready. You have to be ready to adjust, and you have to have the technical capability to adjust.
Yeah.
And the technology in that field, I'm sure 7 years, right, from that initial point to that launch. So whatever maybe you were working on in year 1, 2, 3 had probably changed, evolved, improved. And so by the time you're actually implementing it, ready for that takeoff, it maybe doesn't even look anymore like the technology you were kind of exploring in that first couple of years.
Yeah, no, for sure. I mean, that's one of the challenges of being an architect, is that you have to make your technology selection very far out. So you have to have a kind of a good feel for the technologies that the industry wants to use 5 years from now, because that's when your thing's going to get built. Right?
Yeah. Oh yes, we had nice photos as well.
Side by side, we're going to have photos in between these.
So this is your life on the left, and this is their life on the right. Right, so the next question, I'm going to go on the other side here, so I'm not tucked away. Do you put regular data center switches on the rocket?
So
can you actually answer this one, though?
We can.
Okay.
So this is a question that Lexie and I get a lot. What kind of Cisco switches do you use? Well, the fact of the matter is that rockets are an incredibly dynamic environment. And what I mean by that is that there's extreme hot, right? There's rocket engines that are producing, 3,000 degrees Celsius exhaust. There's extreme cold because you're in space, you're in a vacuum. There's extreme vibration, again, because of the rocket engines. There's shock involved, there's lightning strikes, there's radiation, all the time. I'm sure everybody's heard of the infamous story from TAC where there's some weird problem with your network and it turns out to be a solar ray. Yeah. That's a real thing, right? And it gets way worse the further that you get out into space. So what all this means fundamentally is that it's custom hardware that's required. There's nobody that's building switches, commercially that you can go and use in these kinds of environments. The design and the environments just don't work.
Yeah.
Just toss it on the rocket, yeah. I've been asked if there are hubs on the rocket.
Oh, nice one. Yeah. That's your fault.
I know.
Because you can't stop talking about hubs in your social media. So maybe we need to move on from the hub
now. Maybe this is a sign.
Yeah,
okay.
You've caused a problem.
All right, that's fair. This is just a fun photo.
Can you just tell us about this one quickly? What's this?
This is the fairing that goes on top of the rocket. So if you don't know what a fairing is, I hope I explained this well enough, but
go for it.
It's where the payload goes. So whatever we're going to deploy, you see New Glenn in this photo here at the very, very top, there's the fairing, and it basically covers and protects the payload until it's ready to deploy, and then it opens up, and that happens at a certain point in the mission.
It's supposed to.
It's supposed to. It did when we flew it in January. So.
Yep. Nice. And this is a picture prior to that mission. You can see a person for scale kind of down there in the middle. This is an enormous vehicle, right? This it's a 7-meter diameter fairing. The vehicle is almost 300 feet tall, so this first payload that we put up was actually a prototype for another vehicle that we fly called Blue Ring, which we're not going to get into, but if you're interested, go look it up because it's very cool.
Nice.
But this was so we flew the first mission of New Glenn with a prototype for another vehicle, which as a company was really cool and kind of a moment of pride that, the current generation and the next generation flying on it is really interesting.
And I don't want to go on a side quest here, but we were just talking yesterday. It felt when the rocket actually took off. And the emotion, I mean...
Well, we were very different, right? I was I cried immediately. I was sobbing. Right?
Yeah, I think for me, when it launched again, I think that I was more in the zone in terms of, operationally thinking about what could happen, making sure that everything looked good. But a couple weeks afterwards, for sure, it kind of hit. There's that moment of reflection of how long that you spent on it, how big of an accomplishment it was. So it was really satisfying.
Cool.
Pretty cool.
Right. So how do you design this network, obviously, to keep the people on the on the spaceship, on the rocket, safe?
So one thing is that it's not just about the people on the rocket, it's also the people on the ground, right? So fundamentally, these rockets are very large bombs that we explode in a controlled way, right? You have fuel and an oxidizer, you put those two things together at certain pressures and they explode. Yeah. And we do that in a very controlled method through the engine. But when all of these things are being loaded onto the vehicle, right? So these are cryogenic fluids. So what that means is that you have methane and you have oxygen, and we have to pressurize both of these things until they become liquid. So the operation of putting these fluids into the tank is a very challenging fluids problem. Yeah. And there's people all around, right? There's operations personnel generally in the area. And of course, all of the things as well, even when you're working in integration, when the vehicle isn't in a fueled condition, you have things that are intended to move, right? You have fins, you have control surfaces, and you don't want those things to move when they're not supposed to. So really the thing that's at the core of how we keep humans safe, or the idea of safety critical networking, is something that we call determinism. So determinism is the idea of when you deliver a message, that you always deliver it not only on time, but at a very precise point in time, right? Okay. It's the idea in a traditional QoS sense of having extremely low or zero jitter. And always delivering the packet and always delivering it at the exact right time that it needs to be there. Of course, for any of our experienced engineers in the room, we know that this is a very, very challenging thing to do. So when you're working through these ideas of determinism and you're building your network, you have to think about things from that point of view, of not just the point of view of, I need to deliver my packets, but I need to deliver my packets precisely at the same time, every single time. I always joke, we don't have a number of 9s in our SLA. Our SLA is 100%. If we drop packets, then a very expensive vehicle goes into the ocean, and we don't want to do that.
This might be a silly question because you're talking about delivering that packet. There's some acknowledgement process that the packet was in fact received.
That's probably going a bit deeper than we can go on.
I
things.
Even get sidetracked.
Can't talk about it, Patrick.
Let's carry on. Okay.
This is just another,
Which one's this?
Nuclean is very big.
Yeah.
It's very big. This is, it's the integrated vehicle, but it's kind of like coming out of the IF. This is, I think, the step right before it'll actually go onto the pad and be like up.
Yeah, and again, you can see people for scale.
Yeah.
This is, if you are used to watching, other launch vehicles, be it Falcon 9 or any of the small sats or smaller launchers from like Rocket Lab, this thing is in a whole different class. Okay. It's enormous.
Sure. All right. I love this, because this one really brings in not just the technical skill, but the soft skill, I think, as well. So what skills do we need as network engineers that are operating maybe regular networks, right? You're working right now, and can translate into aerospace.
Yeah, I mean, we talk a lot about soft skills these days. I think like that's been a big thing that we're pushing, and there's a reason for it, right? Yeah. Because I mean, for me personally, the most valuable skills that I look for in people that I work with or might work with, the most valuable skills that I've seen for us as a company is being able to collaboratively work with other engineers who may not have the same skill set that you do, right? So I came from a NOC. I was used to having a lot of network engineers around me. We were all kind of on the same page. We understood the same knowledge skill set, right? But in aerospace, you're likely going to be working, especially if you're working on a vehicle like we are, you're likely going to be working with a lot of different kinds of engineers. And so they're going to have a lot of knowledge. They're going to be very intelligent people, but they're not going to have the knowledge that you have. And you're not going to have the knowledge that they have. And so it might sound a little glib, but like being able to work collaboratively with other types of engineers, other very smart people, being able to explain things without being condescending and just have like an overall teamwork attitude is really, really important to mission success. I mean, we all have the same actual mission, right, is to launch this thing successfully. So keeping that in mind, that's a skill.
Yeah, I think, my opinion, I think there's a few things here. Number one is the level of technicality that you're at is more detail-oriented in aerospace than you might think. So the example of this that I always give is when I did my interview at Blue Origin, they asked me for a packet walk. So how many people have done a packet walk in an interview, right? It's a very common interview question. And I thought I had a great answer, right? I was very confident, and I went through all my application layer stuff, went through how does the network lookup work, how do we determine what our default gateway is, all of those sorts of processes. And then I said, and then the packet gets sent out on the wire. And they said, well, what does that mean? And I said, oh, well, I don't know. And, that's as far as I learned. But as it turns out, there's actually an enormous amount that happens between when you're ready to send a packet out on the wire and when it's actually sent out and modulated onto whatever medium that you're sending out. And so for me, that was a moment that I realized I need to up my game. Right? I need to get into 802.3. I need to start reading standards. I need to start testing. I need to start getting into things with an oscilloscope and figuring out what's really going on here. Because it wasn't just a gotcha question in the interview. Genuinely, these are problems that we have to work with all the time because of the types of systems that we have to design, the level of customization. A lot of the time, we're kind of inventing some of these things from the standard principles. So you really have to understand how the standard is supposed to operate, right, at its most fundamental level. So I would say, again, my most recent background being in cloud and data center, that I've gone to the total other end of the scale, right? That I'm very low level and very detail oriented about what's going on so that we can get that determinism that we talked about. Right. Fundamentally, when you get down to the very low level stuff. I think that the other thing that you can do is to understand, Lexie talked about this a little bit, but rockets are a system of systems. So understanding how the network interoperates with other things. How does it operate with, even at the hardware level, right? Like I talked about, how do these Ethernet interfaces interface with each other, really? Yeah. How do the applications interface with each other? How do the applications that are turning a fin or adjusting the thrust level of an engine, how do those things interact with the network? And what does it look like when it's going right, and what does it look like when it's going wrong? So this kind of systems level of approach is really important in aerospace, because if you just focus on, if you think I'm just going to work on the network and that's the only thing that I have to pay attention to, the problem is going to come is that you're going to have some weird high symptom problem that's, I sent the fin a command to turn and it didn't turn as much as it was supposed to, right? What does this mean to the network? Could the network affect this? This is, do we need to go and look at things, or how can we how can we provide the overall troubleshooting? And also I think this is probably more of a transferable skill, but the idea of all hands on deck, right? Right. If you're in a NOC or whatever, and you have a Sev 1 and you need everybody to come in and work on whatever it is, that's multiplied by 100, right, when you're working on something like this. Yeah. And you have to be ready, when we were running up to the launch last year, we had a lot of long days, a lot of long nights, a lot of PTO canceled. And again, it goes back to that, you have to really want this. You have to really want this this project and this thing to be able to succeed. So I would say those are the idea of when it's all hands on deck, that it truly is one team. And it can be everybody from mechanical engineers to people that are evaluating thermal environments to physics to people that are doing orbital dynamics calculations. These huge range of engineers, they're just going to pile everybody in a room and you're going to be in there until a problem's solved. And so that's a mindset for me, having been a few years since I was in operations, that I had to get used to again.
Yeah, that's a really good point. Yeah.
Very cross-functional, but across different teams and different solutions.
Cross-disciplinary,
What's the next photo? There we go.
Engines. I think we were really proud of this one because we had the Blue Origin, on the engines, cap on the engines as we moved it out to the pad.
Nice. Next question, obviously challenges, right, that you face as an architect when you're designing these networks for rockets specifically.
Man, there's a lot.
You already mentioned some, right?
Yeah, as an architect, right, your primary role is to translate the business requirements into actionable engineering, right? To understand what does the business need, what does the business value, not from necessarily the technical requirements side. Your job is to make those technical requirements, right? And in this process, in my past lives, you have a good feedback cycle about this, where you're getting requirements, you're proposing design, you're reviewing that design, presenting it back to the business and saying, hey, is this what you want, right? And then doing these kind of iterative refinements.
Yep.
But we talked about how long that these design cycles are, and so as an architect, it's actually really challenging to have that very long loop on your feedback. We talked about the technology selection in terms of, what do you think are the things that we want to use in 5 years from now when we build this? And in a normal architect sort of position, you would be able to get feedback on that relatively quickly. Is the market picking this thing up? Am I going to Cisco Live and seeing more vendors that are working on whatever this technology is? But you don't have that same feedback in this position. You kind of have this, I don't want to call it an immutable design, but it sort of is, that the design, you don't get feedback on it very often, so in your mental process as an architect, it's very challenging to be able to make sure that you're on the right track, right? Yeah, which is really what you want. Your job is to deliver this thing to the business, right? Yeah. And it's very challenging to do that. I think another thing is, we talked about the lack of availability of commercial hardware. That's a major challenge. There's a lot of things that you assume just work, right? If you want to run a routing protocol, or you want to run a switching protocol, or you want to have certain amounts of interfaces, or you want to put power over your Ethernet interfaces, you can just put out a spec sheet and go to your Cisco SE and say, hey, I need something that does these things. Yep. But not being able to do that, there's just a lot of functionality that's built into modern network hardware that we don't get to access, right? So as an architect, some of the things that you might think about, I might want to use this protocol, or I might want to use this standard. Well, you actually have to kind of go do some preliminary research. Okay, can I actually go make something that supports these things, right? And can I make, not just hardware, but the software and the tooling and those sorts of things that go into it.
Well, you talked about determinism earlier, right? Mm-hmm. And like some of the challenges of creating that for space, faring vehicles include, first of all, we don't have that much commercial hardware available. It's also got to make it through radiation, high temperatures. You're also designing with that in mind, right? Right. Not only everything you just said, but you also have to take that into consideration, right?
Right. It's very hard it's very difficult to find hardware. In fact, when I first started at Blue, I actually reached out to Cisco and some of their custom design people, and I said, I have familiarity with you in the past. We use their products, we trust their products, and then, here's some of our very, very basic requirements. And they were like, no way, right?
They didn't want to go down that path.
Exactly. Yeah. So that part of the challenge, again, from the architect's point of view, is that our volume is very low. If you're an enterprise customer, right, you might be buying 4 or 5, 10,000 switches a year, right? But we're only flying a handful of these things a year, so it's very challenging to get buy-in from a vendor to say, we need to do this really complex, highly custom, highly challenging design effort, and then, by the way, we're going to buy like 1,000 of these ever, right? So that can be a very challenging aspect as well.
Here's our next
picture.
What's
this one, Lexie?
This is it's being put together. I think this is probably mating the 2 stages in the IF. You can see stage 2 over here doesn't have like the payload with fairing or anything attached yet, but we've got stage 1 right here. There's people for scale somewhere in here too.
Yeah, there's someone down here on the ladder or something. There you go.
On the forklift or whatever. Yeah. There you go.
That was our first mission booster. We called it So You're Telling Me There's a Chance.
Oh, there we go. And was that an acronym? And that was spelled out?
No, it's a line from Dumb and Dumber.
Just put it on there. Because I think, what was the context? We were trying to catch the booster.
Right.
This is our very first launch, trying to catch the booster on a ship in the middle of the Atlantic for the very first time.
Yeah. So you're telling me there's
some kind of a chance.
Yeah, I love this one as well, right? What's changed for you, right? From the roles you were in before, obviously, either with an ISP or within a data center, when you did begin working with Blue in particular here.
It's funny, I got my CCNA, worked as a network engineer in a NOC for a while, and I kind of thought I had everything figured out. I had the foundation down, right? Yeah. Thanks to getting my CCNA and studying hard for that, and then I got to put that into practice. Yeah. But then moving into aerospace, it's I had to learn a new network, and it's the only network like that in the world. There's no other network like it.
Very niche, no?
Very niche, right? So I went from feeling like I had everything figured out to like I'm never ever the smartest person in the room. There's no chance of that, and I don't know what's going on half the time. And I had to get used to like being uncomfortable and like being okay with that.
Yeah.
And having a little humility about that, but also like you have the foundation down, and that's good, and you should always keep that. But then you have to think outside the box.
Yep.
And actually, I found that thinking, at least for me, thinking outside the box, like I had no design or architect experience at all. Thinking outside the box was really, really hard because you kind of have this mindset after you get like your certs and you're like you're on the path, and it's like this is how it should be. But it doesn't have to be that way. You can. The sky's literally not the limit anymore, right? Especially with this work. So, getting used to understanding.
You got that one. Yeah.
Getting used to understanding, that you're going to be uncomfortable. You're going to learn new things every day, and what your preconceived notions of what is right may not be the only thing that's right. Networking can work differently than you think it can.
Yeah.
So, how about you?
Yeah, I think for me, this was a deliberate career change for me. So my previous job I loved. Great company, really interesting, but what I found myself doing was kind of, we're going to solve this problem, and then now we need to solve it for a slightly larger scale, and a slightly larger scale. And so I really kind of wanted to blow up my engineering mindset, right? And I wanted to go someplace that I didn't really know anything, and that I was going to have to think about problems differently.
Right.
That was really interesting to me. And so it did, right? I came in, I was a distinguished engineer at my previous job, and I came in and, there's people fresh out of college that are teaching me everything, right? I'm learning about all of these different things about aerospace engineering, about aerospace development processes, about avionics, things that I had no clue about. So I think that my major thing is it's the malleability and humility, right? Being able to learn new things, being humble enough to understand that no matter how well accomplished that you are in your career, there's always more to learn. Right? There's always more to figure out. There's always things that you don't know that somebody else might know. And again, from the architect's point of view, it's extremely important to keep that humility, because you never know who's going to have some good idea that you didn't think of, because all these solutions are so custom and so off the wall. You might hear something from some random systems engineer that triggers something in your head. So you just always have to have that open mind about not immediately saying no to things.
Like you said earlier, it's collaborative, right?
Yep.
And you all want the same result at the end. You'd like
Right.
this rocket to actually take off and complete its mission. So that makes sense.
Yeah, it's a good way to put it, not saying no immediately.
Yeah, exactly. What are you talking about?
We tend to kind of want
hang
to
on
do
a
that,
second.
We think we know everything.
Yeah.
And then, So here's our last big picture. This was, I think, a hot fire photo. No, this is a photo of actually right before it launched of the engines. Just a nice little close-up in the sunset. Cape Canaveral, Florida.
Yeah.
Anyway, launch your career with us. We do have blueorigin.com/careers. We do have network engineering positions pop up every once in a while. So if you're interested in something like this, feel free to contact either of us. Our information's here. I'm also on Blue Sky and social media and stuff as Track Pacer. But yeah, keep your eyes on the skies.
And we did modify the slide deck a tiny little bit for the session this morning. So if you've downloaded the one that was in the app, it might not have that slide. So what I'll do is I'm going to upload this version of the deck in the WebEx space, or you can grab a quick photo. I'll get out of the way if you need the emails. And like I said, we're wrapping up because our half hour is done. Thank you so much for coming today and talking about networking in space. Notice how we got away from not asking about BGP or anything like that. And like I said, if you have some questions for them, please feel free to hang out with them just outside the CiscoU Theater. Thanks for coming, everyone. Appreciate it.
Thanks, everyone.